and our weight is 29. So our difference, we take 30 minus 29, which is 1. Then we take that difference to this table. As you can see here, we said the readings from our dry bulb thermometer, it is 29. But from our table, it's not there. Is it? The readings are from 28 to 30, so we'll use 28. As you can see here. And the difference was 1. As you can see it over here, you check the intersection between this table. 28 and 1, which is 93. So our air is saturated. There is the probability of getting rainfall. May I welcome my fellow to continue with the demonstration about temperature. Thank you.
I'm going to talk about the 6-inch thermometer. As the name 6-inch thermometer.
Introduce yourself.
Okay, my name is Brigitte Fabian from 6 EGM. I'm going to talk about the 6-inch thermometer. Thermometer, as its name, comes from the Greek word. Thermo means heat and meter means to measure. 6-inch thermometer is comprised of 2 readings, that is maximum and minimum. The minimum is comprised of alcohol and maximum is mercury. Whereas the maximum, the reading is taken from, whereas the maximum temperature, when it expands, when mercury expands, the indices pushes upward. Whereas when it falls, the index remains at its position. When we take a magnet so as to reset the index. In the minimum, the reading is also taken as below the index, whereas when the alcohol pushes, the index remains, it's below. Thank you.
My name is Ali Rashid. I'm in Form 6 CBG. The guest of honor to see is the rain gauge. This instrument is used to measure the amount of rainfall per days or monthly or annually. And this equipment is composed of this funnel. This funnel, its function is to take the droplets from the atmosphere into the measuring cylinder. In the measuring cylinder, there is readings, as you can see now. We put some amount of water in order to get the readings. Here, it is the readings in form of liters. As you can see now, we have 1/5 liters. This is approximated as 0.5 liters. So the amount of rainfall is 0.5 liters. These liters you can convert into different units such as inches, mils, whatever. And also we have wine sock. Wine sock, it's an instrument which is used to measure the direction and the strength of the wind. You can see now at the moment the wind blows from north-south. As you can see the direction of one sock. Yeah. But during morning, the wind blows from north to south, as you can see, but during evening, the wind blows from south to north. Yeah. Also, this rain gauge have different applications. This can be applied in agriculture by the farmers so that to know how different seasons of cultivate. And also we can use windsock in aviation activities during taking off and landing of airplane. Thank you.
Once again, my name is Brigitte Fabian from 6 EGM.
My name is Salum Ali Mwendra from 6 EGM.
My name is Ali Rashid. I'm from 6 CBGs.
You're
welcome. Thank you.
Welcome guests of honor, school director, head of school, teachers and other invited guests. Good afternoon. My name is Zian Oscar. I am from Form 6 PCB class and I'm from the physics department. I am here to demonstrate the wind generator as you see here. This wind generator here you see, it's a windmill generator. It is used to convert wind energy into electrical energy. How does it do that? It converts rotational energy into electricity. But before that, let us see its part. Here we have a tower. Right here we have 4 indicators, and above there we have the motor. In front here we have the blades, and here we have the wind directing tails. Okay, how does this work? When there is high speed of wind, these blades right here will rotate at a high speed. And this rotation here, it is a mechanical energy. So it will be transferred into the motor up there, and the motor will convert that energy into electrical energy so as to produce electricity. How can we know that electricity is produced? We can know that by looking at these indicators right here. When the wind is very high, there is high wind speed, these blades will rotate at a very high speed, so that means that electricity will be produced at a very high rate. So all of these 4 bulbs will light. But when wind speed is very very small electricity will be produced. Hence, only 1 bulb here will light. Why is this? What is the importance of this windmill generator? First of all, it generates electricity. But the benefit of this windmill generator is that it is environmental friendly. It does not pollute the environment. As we know, there are some other generators which use chemicals to develop electricity. But our generator right here, it is environmental friendly. It is not very windy today, but I will try my best for you to observe how it can do. So, if you please may come and stand here with me. Please closely observe those lights right there, as my friend is going to try to rotate this blade. Okay. Okay, I wanted you to observe, but you should just use a little bit of more energy to push this thing. But when you actually push it with a little bit of energy, just as strong as the wind, the lights here will light up. Thank you.
Welcome, dear guests of honor, school director, heads of schools, and all invited guests. In front of you, this is the math department, and before all, my name is Framuyabi. I'm Delela Salim.
Kelvin Noni.
Without going far, let's start with the meaning of trigonometry. Trigonometry is a branch of mathematics dealing with measurements of angles, length, and height. Trigonometric angle detector, this is the device used to detect angles of special answers. For example, in mathematics, we have got 3 ratios, which is sine, cosine, and tangent. But also we have got 5 special angles, which is 90, 0, 30, 45, and 60. But before going anywhere, let's start with the trigonometric angle detector circuit diagram. Dear guests of honor, as you can see, we have got angle searching wire and answer searching wire. But so as our circuit to be complete, we have to join angle searching wire and answer searching wire. Therefore, our circuit will be complete. So as our circuit to be complete, and to give us the sure, the diode will turn on, and the buzzer will alert us that the answer is true. Thank you, and I would welcome my professors to continue.
Thank you very much. As I know that, dear guest of honor, school director, with heads of school, together with all invited guests, are eager to see how this trigonometric angle detector is able to detect certain answers of a certain ratios angle. So as explained before, we have three ratios in trigonometry, which are cosine, sine, and tangent. So as you see, this math model, we have got the two poles, which are wires, pole 1 and pole 2. As explained before, that we'll be having angle searching wire, and that one is answer searching wire. So this diode to light up and the buzzer to be ringing so as to show that the answer is the correct for a certain ratios angle will light up. So for it to light up, it must be a complete circuit. For example here, it's a complete circuit. As you can see, the diode is lighting up, but also the buzzer is ringing. Can you hear that? Okay, thank you. I will start by finding, as you can see, it is not ringing, either the diode is not lighting up, to show that's not the real answer. Yes, still not the answer, 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 not the answer. As you can see, now tangent of 45 is positive 1. Shifting to another ratio, that is sine. Sine of 30. That's not the answer. Not the answer. Not the answer. Still no answer. Not the answer. As you can see, it is lighting up, but also the buzzer is ringing. So sine of 30 is 0.5 or half. Now shifting to the last ratio, that is cosine, I will start with cosine of 90. Not the answer. As you can see, cosine of 90 is 0. So as explained before in the trigonometric angle circuit diagram, that is how it is practiced practically. Now in general, we have the applications. We have the applications of trigonometry in general. As well described here, the basic measurements of trigonometry angle and length. Now, the applications, in road constructions, trigonometry is being applied. For example, as you see in these beams, there are two diagrams of right angle triangle. So for these beams to be stable, there must be the calculation of a certain angle that correlates with the height there, as you can see. But also in landing of flights, the pilot has to calculate that at a certain angle, this will be safe for an airplane to land. As you can see here, there is 12 kilometers, but also at the angle of 50. So through this angle and that kilometer, the plane will land safely. But also in astronomy, that trigonometry is applied in calculating the distance between sun and earth or any planet, as you can see there. And there is also application of angles. And lastly is in computer music. As we know, sound travels in form of waves, repeating wave pattern, which when drawn graphically, there are sine and cosine functions, which are ratios of trigonometry. So these are the application of trigonometry in real life. But also, now coming to the importance of our model here, trigonometry angle detector. Firstly, it's simple to use when compared to this one. As you can see, this is mathematical table. It requires some skills, so as you can be able to find certain answer of certain ratios angle. But also, we have a calculator. This is also requires some skills, so as to know. But with this one, even a standard 2 will be just doing trial and error. For example, he or she must be knowing that this wire is angle searching wire, and that second wire is answer searching wire. So he or she will be just using this angle searching wire. He or she puts in a certain angle here, and then the other one will be in this cycle here. These are the answers. So he or she will be just tapping the nails here to see when the diode lights up and the buzzer rings. He or she knows that, maybe tan of 45 is positive 1. Thank you.
Dear guest of honor, I hope you have enjoyed the demonstration. This is mathematics department, and I would like to encourage you to bring your cousins, siblings, and whatever to our school so that they can learn mathematics in practical way. Thank you. Welcome again.
Haya, picha kuna mgeni hapa. Picha. Picha mtangazie kwenye mic.
Bostino.
Huyu. Ndugu wangu, nakutuma logo imeshakuja ile kule kaikata. Wamekansa.
Welcome dear guests of honor, schools, teachers, and then teaching staff, and other invited guests. Good morning. As you can see here, we have soil. As you can see here, we have different types of soils, each samples, like sample 1, sample 2, sample 3, up to sample 6. Okay, first of all, we have to know about soil. My name is Jackson Isaac from 6 CDG. First of all, soil is a layer of organic matter and inorganic colored material found on the earth's surface that are capable for sustained plant growth. Okay. These soil are categorized into different properties, as you can see. Today, we'll give you just two main properties. That's first is soil color. As you can see here, into different samples, we have different colors. We have red color, we have brown color, we have gray color, we have black color, we have reddish, we have light color, as you can see there. But what the reason that made this soil to appear into different colors? As you can see, we have two main reasons. One, it's mineralogical composition of the parent rock, as you can see here. Me, I'm black like a midnight. I'm originated from my parents, as you can see. So this soil, as you can see, I've into red. I've originated to the parent rock, as you can see. Soil color varies into place to places. As you can see, when you move to different places, you face different colors with different soils with different colors. As you can see here, with different soil appears into different colors and where they originate from. Second reason is about organic matter. Organic matter, when I say about organic matter, it's about the decomposition of organic matter. When I say about humus and other things. Okay, but mind you, not all soil have the same organic material or the same minerals. Because that's why they appeared into different rocks, as you can see. Thank you.
Well, my name is Faith, and I'm going to talk about the second property, which is soil texture. Soil texture is the relative amount of different size from one, and I'm going to talk about soil texture. Soil texture is the relative amount of different size of soil particles. As you can see here, we have got different size of soil particles. We have this one, which has smallest particles, and it is the mixture of all other particles, of all other size. And this one, it is large size. And this one, with this one, it is the smallest size. And this one is the smallest size. Well, this one it is sand soil, which is found on the large size. While this one and this one it is silt soil, which is found on the smaller size. And this is silt soil, it is clay soil, which is found on the smallest size. And this is the one which is called loam, which is the mixture of clay soil, sand soil, and silt soil. And the clay soil we had here, it is found because of the soil structure. The soil structure we had here, it is wet, it is dry. The soil structure, it is dry when it is formed by rain. And also, when it becomes wet, it is slippery and it is departing from itself. Thank you.
Okay, thank you, sir. Thank you, sir, for your preparations. Now it's our end.
Thank you.
As you can see here, soil is applied in our daily life through pastoralism, their agriculture, and also pottery. I'm here to tell you about how it's applied in pastoralism. The soil supports the growth of the plants, and those plants are used as pasture for our domestic animals, for example, cattle and goats. As you can see, the modern days, there are also masters that pass around, finding in search of the grass that is used as for food for the domestic animals. Thank you. And now for the next demonstration from our friend Free. Kajel.
And here is all about pottery. Pottery, it's all about the making of things by using clay soil. The clay soil we had here, it is formed by two colors. We had this one, which is formed by red color, and the one which is black in color. The red color, it is the one which is made by the soil we saw there, and also we have a sample which is this one. And the black one, it is this one by making sample of these things. And here we have a charcoal stove, which one it is used by the early people in early age. Until now, in rural areas, they're still using it. And in Kiswahili, they're calling it mafiga if you don't know. Thank you.
Well, that is a small plot of farm shown there.
Thank you. Welcome to our fourth demonstration. This is where we are going to show how blocks are made and how the house is made. We take the dry clay soil, we mix with water, we make the blocks. The blocks will be ready after 3 to 5 days. They will be ready for construction. This is an example of a pre-unit class is made here. It will be ready before January, and the pupils will be able to enter in the class and study. And this is why we are saying St.Matthew is the best. You move with many things you can do. And you can invite us to build for you a house. We can build a good house for you.